Lesson 3, Solving Quadratics Graphically. So what solving means is it means where your x-intercepts are will always solve your quadratic. So there's three possibilities. The first is that you would have 0 answers, so either it would be above it or below it. So you'd have 0 intercepts or 0 solutions. You could have 1 solution, knowing that it goes right down and touches the line. Or you could have 2, where it goes through 2 times. So there's a maximum amount of intercepts of 2 and a minimum of 0. So first we're going to rearrange into standard forms, because sometimes it's easier to graph and you need to be able to graph from standard form. So to do this, we're going to distribute into our brackets. So we have 8x minus 2x squared, and then we're going to move everything to the other side. So subtract 8x, add 2x, so this makes 0, this makes 5x squared, minus 14x plus 5 equals 0. So there is our quadratic function in standard form. For example 1, the flight time for a ski jumper depends on the velocity of the jump. The jumper's height, h of t, in meters over time is modeled by the following equation. H of t is equal to 5.0 plus 24.46 t minus 4.9, this should say t squared. The graph can be used to determine when the skier is 4 meters above the water. So what it's saying is it's holding his height at 4 meters. So what we want to do is we want to substitute our height to be equal to 4. So we have 4 equals 5.0 plus 24.46 minus 4.9 t squared. This is a t. Now we already have it graphed, and I used a graphing calculator to do this. And our x-intercepts are at x equals negative 0.04055 and x equals 5.03239. Now to show that this is the solution, we're going to substitute that in for x, and it should equal 4, or close to it. So we're going to do 5 plus 24.46 times negative 0.04055 minus, running out of room, 4.9 times negative 0.04055 squared. So remember, our x's are negative 0.04055, and the other one was 5.03239. Now we could graph this on our own, but because they're such small decimals, we wouldn't have ours exact as close as this is. So when you type this into your equation, you should get, or into your calculator, you should get 4.000089918. So basically it's 4. So we know that when x is negative 0.04055, he would be holding it for 4 seconds. The only thing is you can't have a time of a negative. So we know that this is not a solution. We would call it an inadmissible solution. It doesn't actually work. So now we're going to try the other one. So 4 is equal to 5 plus 24.46 times 5.03239 minus 4.9 times 5.03239 squared. Type this into your calculator, and you should get 4.000008751. So really close to 4. So we know that the skier holds his position 5 seconds, for about 5 seconds. For the next example, y equals x squared minus x minus 6, we want to graph this. So we're going to find a table of values first. And I always do 0 first, so y equals 0 minus 6. Y equals 1 squared minus 1 minus 6. And you should get 1 minus 1 is 0, minus 6 is negative 6. Y equals negative 1 squared minus 1 minus negative 1 minus 6. So 1 plus 1 is 2, minus 6 is negative 4. And we already found our middle spot, so that means 2 would be negative 4. We can try it for 3 as well. 3 squared minus 3 minus 6. 9 minus 3 is 6. Minus 6 is 0. So this would be 0, and negative 2 would also be 0, because we know that everything reflects across the axis of symmetry. Our axis of symmetry is x equals, we don't know yet because we didn't find that vertex. So x is equal to 0 plus 1 divided by 2, which is 0.5. So our axis of symmetry is at 0.5. Our y would be 0.5 squared minus 0.5 minus 6, which equals negative 6.25. So our vertex is at 0.5, negative 6.25. So we're going to graph this. And we're trying to find the solution. So we want to know when y is equal to 0, because those are our x-intercepts. So we'll graph that. So at negative 2 and 0, at 3 and 0, our vertex is at 0.5 and negative 6.25. So there and there, negative 4, and here's our graph. So our solutions is our x-intercepts. So our x-intercepts are negative 2 and 0 and 3 and 0. So that's how you find your x-intercepts from the graph.